afternoon, everyone. So it looks like we pretty much squeezed in as much as possible, so those of you on the side will enjoy the show too. So good afternoon. I'm Jeff Hoffman, professor in the Aeronautics and Astronautics Department and director of the Massachusetts Space Grant Consortium. And as director of the Massachusetts Space Grant, it's really my great pleasure to welcome you all here today to hear our annual Space Grant Distinguished Lecturer. MIT is the lead institution of the Massachusetts Space Grant Consortium, which consists of over a dozen colleges and universities, as well as research institutes and museums spanning the state from Cape Cod to the Berkshires. We're one of 52 national space grant organizations supported by NASA in every state, as well as Washington, D.C. and Puerto Rico. Space grant programs vary according to the needs of individual states, but the overriding purpose of Space Grant is to encourage students to participate in space-related research and to pursue space-related careers, to assist teachers in introducing space-related material into their curricula, and to inform the public about space-related activities. And here in Massachusetts, for example, we provide fellowship support for dozens of students every year, enabling them to participate in summer programs at NASA centers as well as in space research activities at their own home institutions. Together with the Museum of Science, every fall we put on a Massachusetts Space Day where hundreds of high school students get to hear about the research done by university students sponsored by Space Grant and then listen to a NASA astronaut talk about spaceflight. A long-standing tradition of the Massachusetts Space Grant is to invite a distinguished lecturer to address the public every spring. Well, it's almost spring, anyway. In this series, we've had a Nobel laureate, several aerospace company CEOs, a few NASA associate administrators, center directors, astronauts, and NASA chief scientists, but never before a NASA administrator, as we have today. Mike Griffin took over the leadership of NASA nearly 1 year ago. You can read all about Dr. Griffin's distinguished career in the brochure that was handed out as you came in, and I'm not going to repeat it here. What was not in the brochure is the fact that Dr. Griffin does not like to stand on ceremony, and hence Dr. Griffin usually gives way to a much more simple and informal Mike. And what was also not in the brochure is an insight into the enormous challenges that Mike has been dealing with at NASA. He's trying to lead our country back to the moon and beyond, recreating the capabilities that we once had back in the time of Apollo, but which we allowed to disappear. Now, most of you students who were here weren't even alive during the Apollo program. It's ancient history. It's a heroic age. But I know from speaking with a lot of you that the idea that you students can now once again take part personally in the human exploration of the solar system has spread incredible excitement through your ranks. Remember though, this time we want the exploration to be sustainable so that we don't just go to the moon a few times and stop, but use it as a stepping off place to the rest of the solar system. And we have to do it with a relatively constant budget, not with the crash program that was Apollo. And while we're recreating this capability, we have to bring the shuttle back to flight status and operate it safely for another 5 years while we're completing the construction of the International Space Station and hopefully service the Hubble Space Telescope one last time. And we have to do our best to maintain the science program that have won NASA worldwide admiration. Well, by any standards, this is a tall order. Maybe it's trying to put 10 gallons into a 5-gallon can, but Mike has accepted this challenge with determination and with humility. He certainly is uniquely qualified to lead NASA into this new era with experience in government, industry, the military, and academia. He's a true rocket scientist and knows the space business like few others. He's brought about major changes in NASA in just the 1 year that he's been at the helm, and we'll watch with great interest the continued evolution of the agency. Mike, I know you give lots of talks to many different audiences, but I doubt if you'll meet up with an audience containing as many absolute space nuts as we have here today. We're impressed by the magnitude of the task ahead, and we wish you success in meeting these challenges. MIT shares a very long and proud history of cooperation with NASA, and we look forward to working with you to make the vision for space exploration a reality. We're delighted that you've been able to come to speak with us today, and we look forward to hearing what you have to say. Ladies and gentlemen, let's welcome the NASA Administrator, Mike Griffin.
Thank you. Thanks, Jeff. Raise your hand in the back if you can hear me. Somebody, great, thanks. Worthwhile to check that now and then. Jeff, what time do we need to be done by?
Well, we'll have a cab waiting for you at 4:30. It's only 10 past 3. We've got time for questions.
So we're good. Okay, great. I just didn't.
Make sure you get out there on time.
Sure, I just didn't want to rush if everyone had to be out or good. Thanks for the introduction. That's way better than I deserve by a whole lot. I only have so much distinguishedness to go in me, and I have to save most of it for Congress. So y'all only get a little bit of any distinguishedness that I might have to go around. I wanted to talk with you all today about our exploration architecture, how we intend to return to the moon, how it fits as we fast forward to go to Mars, a little bit maybe in Q&A about why it is what it is. I could almost say I'm here with NASA, so read my view graphs. But I'm not going to read them to you. I'm going to talk about what's important about each one because they're going to be on your website and you're going to have those to read more carefully yourselves. And I've always hated presentations where somebody sat and read the view graphs to me. So with that, let's step forward. Why are we doing this? As I've had occasion to remark a couple of times today to some students who've asked the question, you know, what is all this about? The vision for space exploration comes about, sadly, in the wake of the loss of our second space shuttle, Columbia, in flight, and the realization on the part of the Columbia Accident Investigation Board that what we do in spaceflight is expensive, difficult, and dangerous, but that it is also strategic for the United States in many different ways, and we should not cease. But if we're going to do it, the goals of the enterprise have to be worthy of the costs, the risks, the difficulty. We need loftier goals, in Hal Gaiman's words. And that flying the shuttle to the space station can at most be a step along the way. It is not the goal, as it had been for the last 30 years and more in the American space program. Most of that, and in fact much more, was captured in Chapter 9 of the Columbia Accident Investigation Board's report. I think we are, as a nation, indebted to Admiral Gaiman and the people who assisted him in going beyond the proximate cause of the loss of the orbiter and getting to deeper issues. I think without that, I would not be standing here today. Because the President listened, his assistants in the administration listened, and they crafted a far-reaching policy for NASA that goes beyond the shuttle and the station and what we're doing today or in any given administration. After the kind of discussion and debate that you would expect, and I was privileged to be a part of that debate as someone outside NASA and therefore an expert witness. Once I joined NASA, my IQ went way down. I'm no longer considered an expert. But while I was outside NASA, I was privileged to be part of that debate. And after a year or two of discussion, this vision for space exploration for NASA and the civil space program was adopted by the Congress, and in fact, hugely ratified. It was adopted unanimously in the final passage of the 2005 Space Act authorization for NASA, in which it is declared substantively that the goals of the U.S. space program are as you see them here. We will finish the space station. We will use the shuttle to do so. We will retire the shuttle in 2010. We will develop a replacement capability to put humans in orbit and beyond, as well as cargo, that will substantially replace the capabilities of the space shuttle, but in a different way. We will return to the moon no later than 2020, and we will work to extend human presence across the solar system. In concert, we will implement a sustained and affordable balance between the human and robotic program, and we will use all this to promote international and commercial participation. Why do we do it? For me, there are many reasons. Some of them are captured here on this slide. The principal ones are captured. But I will say that for me, bullets 1 and 2 are the most important. The human curiosity that leads to the desire to explore is quite literally wired into our DNA. All of us here in North America or in the Americas are the descendants of people who chose to leave their homes and come here. In fact, all of us who aren't living in Africa are the descendants of people who chose to come somewhere else. It is wired into us, and when humans could only master the land, that's what we did. When we learned to master the sea, that's what we did. The 20th century was about the conquest of the air. It will be a while before we can say that we have conquered space, if we ever do. So, but it is something that makes us what we are. We can't afford to spend a significant portion of our national treasure on it, but we spend some, and I think we should. We spend 0.7% of our budget on it, 15 cents for the average person for every day. I've said this several times because it usually gets at least a chuckle, but I spend more than that on chewing gum. And every time I hit a golf ball into a lake, I use up my month of NASA's budget. So we don't spend a lot on space exploration. But it is not an expenditure that we should do without. The second reason, of course, is that, well, I am an American. I'm proud to be one. I think that our nation is and should continue to be a leader among nations. I think the more opportunities that we have to partner with other nations, to create allies rather than adversaries, make our nation, make the human species stronger and better. Space exploration affords us an opportunity for benign, cooperative American leadership on a basis that I believe, given our stature in the world, should be and should continue to be a first among equals, but recognizing that we do have equals. But that this is something we want to do and want to do together. I think it strengthens our nation, strengthens our society, strengthens the species. And it's, if there were no other value that we got from space exploration other than the cooperative benefits from working with other nations in the world, I believe it would justify itself on those merits alone. That's a personal belief, but it is mine. Why are we going back to the moon? I get asked that question at nearly every venue at which I pop up, and so I'll just preemptively answer it. We want to go to Mars and beyond. We've been to the moon, so why are we going back? Well, first of all, yes, people have been to the moon for a cumulative time of 1 man-month on a landmass the size of Africa. I don't think that we can claim to have explored the moon. I personally find the moon to be an interesting place from a scientific perspective, and especially from an engineering perspective in terms of what we will learn to do with it in learning how to fly in space and live in space and work off-planet. A long time ago, I believe it was Kraft Ericke, one of the Peenemünde pioneers, who said that if God had wanted man to explore space, he would have given us a moon. He was tongue-in-cheek. He knew we had a moon. So I think it is important to use that moon, both for what may be there that we don't know about, for what is there that we do know about, and for what we can learn about living off-planet before we extend our reach further. As I said earlier today and have said in other venues, before we can go to Mars, we need to learn how to assemble a space station-sized payload, 400 or 500 metric tons in low Earth orbit, without taking 15 years to do it. We need to do it in a few months. And before we can go to Mars, we need to know how to seal a crew inside a submarine, tell them to push off, and not show their heads again for 2.5 years. We can't do that today. Not with any certainty that they, in fact, will come back alive. And until we can do it, we aren't ready to go to Mars. We will learn to do it by voyaging to the moon and living on the moon. And again, the moon is interesting of itself. There are fundamental issues of astronomy, physics, astrobiology, historical geology, which we may be able to settle in utilizing the moon. What we've proposed is, as an architecture, and this was a discussion about our space architecture, what we've proposed is an architecture that, with as little fuss and bother as possible and making use to the maximum extent that we could do it, possibly, the things that we already owned and creating the fewest new things, does the following. It meets our human spaceflight goals. It offers us a reasonably significant advance over Apollo in terms of crew time on the moon for the money. It is sized to operate with reasonable efficiency at 2 lunar missions per year, 6 months apart, sort of like a space station crew rotation cycle, but of course could do more. It leaves behind 125 metric ton launch capacity for going to Mars, and you'll appreciate that if I need 400 or 500 tons to go to Mars, that's 4 or 5 launches of this vehicle, even allowing for some tare weight, as opposed to how many dozen Space Shuttle and Soyuz and Progress launches to build the space station. A much better approach. This is a much safer system. The probabilities of loss of crew are cited there. It does meet our agreed upon international obligations for servicing the space station, provides an orderly transition of the shuttle workforce, and can be bought by the yard, allows us, allows go as you pay budget planning. Lunar surface activities offer us an early demonstration of human exploration beyond low Earth orbit. We learn how to operate away from the Earth, but only 3 days from home. I think no one will be surprised if I say that there are things about living off planet that we don't yet know, despite having had 6 voyages to the moon 35 years ago. I believe we should keep our hubris in check, recognizing that we need to learn a few things. We certainly can conduct numerous scientific investigations with the moon as a natural laboratory. One of the most important things in developing a more efficient spaceflight architecture will be learning to, in quotes, live off the land in space or on the planets and asteroids that we visit. In places, the lunar crust is as much as 40% oxygen by weight. It's at least 15% by weight most everywhere that we've sampled. And the oxygen is available for human use by heating it up. We need to learn how to do that in an automated fashion because oxygen is 7/8 by weight of the most efficient chemical propulsion combination we're going to be using for a while, liquid oxygen and liquid hydrogen. So if you can, and voyaging to and from the moon, the mass fraction required for propellant is about 50%. So if 50% of your mass in space is propellant and 7/8 of that is liquid oxygen that you can get from the moon rather than hauling it up from the surface of the Earth, I would suggest that one of the earliest economic returns from utilizing the moon would be to generate and ship liquid oxygen. It's going to be a while before we learn how to do it, but I think we will. And of course, we begin to establish an Antarctic-style outpost, 1 mission at a time, and also testing of the techniques and technologies that we're going to need to go to Mars and past that. Now, in contrast to Apollo, we are planning an architecture that offers global access because to scientists and engineers both, the polar regions of the moon offer some of the most interesting sights, whereas Apollo, as you can see from this chart, was restricted to the near equatorial band. The far side, of course, is also of interest. One of the more interesting places is near the lunar South Pole on the far side in the Aitken Basin, where within close proximity to one another, there are sites for possible lunar bases that have access to 24-hour a day, full-time sunlight, as well as to permanently shadowed craters. There's evidence from Lunar Prospector and Clementine of elevated quantities of hydrogen, And if we can find both hydrogen and oxygen on the moon, then that will be the germ of a truly valuable space economy. We won't find it out without going there, and so some of our early plans are focused on the Aitken Basin and Shackleton Crater. We will also need many different things besides merely the transportation to get to the moon. Power systems, communications, rovers, habitat laboratory modules. I'll talk a little bit about those in a moment in the context of international and commercial opportunities. Let me review the flight plan with you. I think maybe many of you here who do have an interest in space, and if anybody does, it's MIT students and faculty. 33 of your compatriots have been NASA astronauts, including my host today. A good portion of you may be looking at the hardware that one day some of you will fly. So the flight plan starts with a heavy lift launch that allows us to take the Earth departure stage and the lander into low Earth orbit. We're utilizing a combined Earth orbit rendezvous and lunar orbit rendezvous scheme for a variety of reasons. It seemed to us to come out ahead in the architectural studies that we did. And following the heavy lifter, if that gets to orbit safely, we would launch the crew. Crew docks, departs from Earth orbit, flies to the moon, deploys into low Earth orbit, leaves the crew exploration behind without crew in at this time, and lands on the moon. Once on the moon, you do what you're going to do, eventually come home, rendezvous, dock, return to Earth. Nothing magic here, and not much that you didn't see in Apollo. One thing, as I say in every venue in which I give this demonstration, the heavy lifter and the crew launch vehicle and the crew exploration vehicle are probably pretty solid. If you look at those, you'll see the designs will be flying in just a few years. As I commented earlier to my old friend Ed Crawley, don't fall in love with the lunar lander. In fact, don't even do any heavy dating, because what the lunar lander is at this point is a weight allocation. And we don't want to commit too early to what the systems designed for the lander ought to be. And in fact, I think Ed and some of his students are taking a look at that as one independent body for us. But the CEV, while not very elegant, offered a number of advantages to us. First of all, we ended up deciding on the Apollo shape, the outer mold lines. We have an extensive aero database on that. The 5.5 meters there has since been downsized to 5 meters to make it fit within the, actually there were several issues. One was the weight margin that we wanted to have with the launch vehicle. Another was if we have to do a launch abort, the 5.5 meter base diameter gave us a fairly large projected area, which produced a fair amount of aerodynamic drag in getting off the launch vehicle. And in order to reduce that to tolerable levels that we could deal with an escape rocket, we shrunk it from 5.5 to 5 meters. But it still offers a quite significant increase in volume from Apollo. We can carry 6 people to low Earth orbit per the terms of NASA's Authorization Act, so we can service the space station as required. We can carry 4 to the moon. As part of a larger mission, this can serve as the vehicle to get the crew up and back at the start or end of a Mars mission. It offers us the flexibility, the service. We expect to have a design in which the service module can fly by itself with unpressurized cargo or operate in a space tug capacity. We are putting forward a system that we think has a pretty good amount of flexibility to do what we need to do with getting people and medium cargo up and down from space for the next several decades. And when I say several decades, I think all of you here appreciate that aerospace systems generally, from DC-3s and B-52s to Soyuz and space shuttles and things like that, expendable launch vehicles, tend to have a very long operational lifetime, decades. They're expensive to design, expensive to build, expensive to keep up, and we don't change them rapidly. So the designs you see for crew and cargo heavy lift are going to be the designs that will take us to Mars. Oops, pardon me. One of our requirements is that the CEV must be capable of servicing the space station, which was one of the things that fell out of our mixed lunar orbit rendezvous and Earth orbit rendezvous scheme. With that scheme, of course, the first step in any mission to the moon, the first step is the launch of the heavy cargo. Provided that goes well, we then launch the crew. But the crucial thing is we stage through low Earth orbit. Well, if we're staging through low Earth orbit, the crew exploration vehicle can go to the space station, or it can dock with the heavy lifter in the lunar cargo. How does it know the difference? Like the old joke about the thermos bottle, right? Keeps hot stuff hot, cold stuff cold. How does it know the difference? The CEV is basically a vehicle designed to fly from the surface of the Earth into low Earth orbit or into cislunar space. That's what it does. And whether it goes to the station or goes to the moon is a matter of largely indifferent matter to the design. So we can meet our obligations in that vein at no real additional. In fact, we were not able to find any significant requirements to serve a space station that were not there in terms of going to the moon. Much like Apollo. Apollo serviced 3 Skylab missions because if a vehicle which could fly to the moon could also fly to the Skylab. The launch systems, of course, are the real key to the transportation. They are of 2 stripes, a 125 metric ton heavy lifter and a 25 metric ton crew lifter. By the way, the heavy lifter is man-rated, and if one only wanted to go to an equatorial region for a particular reason, then the heavy lifter alone with the CEV on top could get you there. But if you want to go to the polar regions, you need more lifting capacity. It will not be lost upon you that these vehicles are derived from shuttle systems. The use of the shuttle solid rocket booster and external tanks is clear. So there are 2 new elements in our architecture, an upper stage for the crew launch vehicle and a CEV. We will be doing things like extending the length of the external tank and quite possibly extending the length of the solid rocket boosters, but fundamentally they are systems we've already paid almost all of the non-recurring engineering development cost in order to create, and we're trying to make use of them as we go forward. I've basically said most of the points on these charts. The third bullet down says that we're building a new LOX hydrogen upper stage, and it says that we are going to use a space shuttle main engine, and that's up in the air. We might use a space shuttle main engine. We might use the Apollo era J2 LOX hydrogen engine because the shuttle main engine requires development to do an air start and is a little big for the burnout thrust. So we're considering a couple possibilities there. But the payload capacities are in the range that are indicated. For the heavy lift cargo vehicle, we'll add a segment onto the solid rocket boosters. By the way, the 5-segment solid rocket booster has in fact already been tested. The heavy lifter as such can put 106 metric tons to low Earth orbit by itself, and if you add the Earth departure stage for the lunar capability, then you can put 125 metric tons in low Earth orbit, of which 55 metric tons can go to the moon. And of course, it's built out of the same man-rated components as we're using today, so it can be used for crew if you want. Earth departure stage is the moral equivalent of the Saturn S4B upper stage, 3rd stage used in the Apollo era. A little bigger, takes the Apollo era model could carry right around 50 metric tons to the moon, that was the translunar injection mass on Apollo 17. This will do about 55 metric tons, so we pick up a little bit. The extra is very nice to have. I think I've already said everything on this chart. Lunar lander will deliver in their initial sizing 4 crew to the surface. I have no doubt that more could be packed in if one wished. It does offer global access. We are sizing the whole thing to be able to land 21 metric tons dry weight, okay, net of fuel to get down. And that's, as I commented earlier, don't fall in love with the configuration. The real thing you want to know is that the architecture will let you land 20 plus metric tons. We want to figure out the lander design that utilizes that in the maximally efficient way. Early on, we're planning on for an ascent and a descent stage, and so we want the ascent stage to be as small as possible because it truly must be thrown away. Whereas the descent stage will be left behind and should be designed or designable in such a way as to offer a lot of leave behind in terms of building up a lunar base, because we're never going to find any resources on the moon more valuable than the tanks and the metal and the electronics that we take down with us in the descent stage. Okay, so we are thinking about those things. In the slightly longer run, we want the lunar lander ascent and descent stage to be one stage and to be reusable, because we want to park it either on the surface or in low lunar orbit and refuel it either from in situ resources developed on the moon or from fuel that is shipped out from Earth. But we don't need to bring a lander every time. We should think about bringing fuel if we have to bring anything. So we're not ready to commit yet to the design of the lander, but this is one concept. Earlier on in the bottom bullet, we were thinking about LOX methane for the ascent stage propulsion because there's good transferability of that to the Mars ascent stage because Bob Zubrin and others have investigated the utility of extracting methane propellant from the Martian atmosphere in a catalytic reaction that uses only a little bit of hydrogen. And that's a neat thing, and we may well do it. There are also other in situ resource extraction possibilities for Mars. So I don't think we're ready to commit to LOX methane. But in any case, we were planning on using it for the ascent stage of the lunar vehicle and removed it from consideration because early on the development cost was going to be quite high, and when we looked at it, it didn't offer any payload advantage for the moon. And doing something now for Mars that doesn't offer a payload advantage for the moon didn't seem to be a fiscally appropriate thing to do, so we will drop back to another propellant combination, maybe LOX ethanol, possibly hypergolics for lunar ascent. There are a number of commercial opportunities, and we want to avail ourselves everywhere we can of the option of purchasing services and goods on a commercial arm's length transaction basis. It is in that fashion that we might have some opportunity to help create a true space economy rather than having everything we do be the result of a government prime contract. We intend to purchase launch services and communication services as soon as they're available, and in fact, I think all of you know that we have allocated, I hope the Congress sustains, we've allocated a $500 million over the next 5 years to help serve as seed money for entrepreneurial or even larger firms who choose to invest in creating a truly commercial cargo and crew carrying capability to be able to service the space station. The space station logistics market is a market that we are willing to, and in fact eager to turn over to industry because we believe that it is incontrovertibly true that if something can be done by industry at all, it can be done cheaper than having the government do it. Most estimates would say at least a factor of 5 or 6 times cheaper, and we'd like to be able to take advantage of that. So we're trying to help bring it about. But as we move forward to the moon, there are rovers to be built, power supplies to be emplaced, communications systems to be orbited around the moon, navigation systems to be put in place. There are a lot of services and goods that we believe we can contract with industry to supply on an arm's length basis, and where they might be able to sell residual services to other enterprises. We hope that can come about. Similarly, there are many opportunities, some of the same opportunities for international cooperation, where other nations can elect to participate with us in going to the moon, so that in exchange for a seat in the lunar lander, maybe they help to build and in place a habitat. Maybe they help to provide communications or a rover or power supplies or an automated cargo lander or. we have tried within NASA to offer an architecture that does a couple of things. First of all, it does the minimum necessary to meet the presidentially stated and congressionally approved objectives. It does not do more. I think we do not want to return to the day where NASA was going to just do everything. We designed an architecture which does what we were told to do, does not do more, but leaves an awful lot of places, a lot of interfaces, a lot of hooks and scars, where either other nations or commercial enterprises can join in to make it grow from a slender reed to a branching tree. The architecture, however, that we've advanced does the crucial thing that only in this era, only the government can do and only the United States government can do, and that is provide robust, we believe safe and reliable transportation for a significant number of people to low Earth orbit and then take them onto the moon. That is the crucial step with which we believe an international program can be forged and without which nothing can happen. And we believe that in this era only the United States can do it. And so that's the part that NASA will do. This is a chart for budget geeks that says our plan fits within, at least in the near term, fits within the budget profile we've been told to expect. This is the chart that sort of my semi-get off the stage chart, but captures what I started out by saying. And this is a couple of quotes from me that against my will, people abstracted from speeches I gave and put into the presentation. So I will let you read them later. And this is a quote from Gene Cernan, which I think is hard to read without a certain sense of humility. I believe that great nations do indeed do great and ambitious things, and that this is something that the United States must do to be a great nation and a great society in the 21st century and beyond. And that's why I took the job. Thank you for your time and attention. I'm yours for questions and for 50 minutes, according to Jeff's schedule. Thank you.
We have a microphone here which we can pass around so everybody will be able to hear the questions. So start raising your hand and we'll try to get things going.
Yes.
Is it on? Yeah. So thank you very much. This was very good. I'm with the MathWorks in Natick, Massachusetts, and of course I have a question about the design process. I read somewhere that you are taking a different approach to design than the traditional spiral-based approach. You want to have a much more direct approach to designing the systems that will eventually take us back to the moon. Could you elaborate on that a little bit, how you think to achieve that in particular, just to contrast it? If you look at the Joint Strike Fighter program, they took a deliberately spiral-based approach, and you chose another. Is there a particular reason for that? So I guess there's two questions.
Well, other than the fact that the GAO published a report saying that the Joint Strike Fighter was overweight, underpowered, short-legged, and couldn't carry much weaponry, that's just the kind of program I want to emulate. Spiral development is a term that, to my knowledge, and I might well be wrong, originated in the software world where one does a continual iteration between capabilities and requirements to grow them ever greater, and has been used in the acquisition world, and the buzzword may have gone in the other direction for all I really know, and it's been used in the DoD acquisition world. You know, I think that's a fine approach when you're talking about production systems or systems that you're designing to go into production, where you'll have a lot of units, a lot of users, and expect to have a long-term evolution of requirements. I would like to get to a point in the space business where we have enough demand and are producing enough units with enough different and growing requirements to be able to say that I thought a spiral development acquisition approach would be useful. It was my judgment that the space business for the next couple of decades will not be that type of business. And it was, frankly, my judgment that we would be lucky to get one spiral. That what we should do is build a system that will meet the stated objectives in the simplest and most direct manner possible, using as much as possible the heritage from components which had already been developed and paid for, and if we absolutely had no other choice, develop some new thing. Very much of a, there's a Japanese phrase, the nail that sticks out is hammered down, that I learned from my roommate in college a million years ago. And there are times when, you know, you want to take a bold new step, and times when maybe you don't want to attract quite so much attention to yourself. We are trying to re-vector the human spaceflight program of the United States from one which has been focused on low Earth orbit for the last 30 years to going to the moon and beyond. And I chose not to put any developmental, I've got enough political hurdles and enough mental hurdles in changing the paradigm of what we do with civil spaceflight in this nation. I did not want to have developmental hurdles. Now, I've spent years doing one new thing after another. I would love nothing more than new developmental challenges. I can't resist at heart being a system engineer. It's what I was born to do. But I restrained myself because we have other problems right now. So that's why it looks the way it looks. Miss, in the front row, the red whatever. I don't know if it was a sweater or a skirt or a blouse. I can't see that well from back here.
Has NASA been considering low-level development of the Atlas or Delta, not as a primary CEV carrier, but as a backup to the shuttle-derived to assure human access to space?
Well, the 5-meter diameter of the CEV allows it to fit nicely on an EELV, an evolved expendable launch vehicle, the Atlas or the Delta, just from a fit point of view. The EELVs would have to grow a bit to accommodate a fully fueled CEV. Their capability to the orbits that we need to go to is in the neighborhood of 20 metric tons or less. I don't know that we can get a CEV down that low. Let me just remind everybody who that the Apollo system, carrying only 3 people to the moon, was a 30 metric ton vehicle, right on the nose. Technology has moved on, structures have gotten lighter, electronics doesn't weigh so much, all right, but getting a fully fueled and loaded CEV down to a weight that the EELV can carry, probably something we can't do. So the EELV is going to maybe have to add another E in front of it for evolved expendable launch vehicle before it could be really useful for us. They may very well do that, and some of the hardest things to change are things like that would be conceptually the simplest, like the base diameter. So our vehicle envelope is compatible with theirs, but at present there's not a direct utility of the EELV family for a crew launch backup. Not to say that there could not be, and we're open to that possibility later on. There are some other issues there. The EELVs don't offer a very robust abort strategy. The trajectories that they fly are rather lofted for efficiency. If I were, and I used to do, designing trajectories, I would want a more lofted trajectory also. But then that makes a very high G-load in getting off the vehicle at certain points in flight, and we really would rather not kill crew if we could avoid it. And sometimes launch vehicles will fail. In fact, 1 in 50 times or so, launch vehicles will fail, so you have to assume that they will fail, and you have to have a robust abort. The EELV in its present form would not provide that. EELVs today are not man-rated. I mean, the Air Force would be the first to tell you that. Why should they man-rate them? We would have to spend a good amount of money to man-rate the vehicles, and the Air Force is not going to do that for free. If we man-rate the vehicles, we either have to have 2 production lines, which there isn't a sane production engineer in the world who wants to do, or everybody is going to have to buy a man-rated vehicle even for an unmanned launch, which of course addresses the DoD requirements. They will not be real fond of paying the extra bill required to buy, copies of a man-rated launch vehicle, because because we needed it to be man-rated. So as a backup or emergency capability, sure, I'd like to reach a state where one day we could do that. I really would. But as a thing that you do routinely, there are sound reasons of programmatics and fiscal policy that would argue to keep those lines separate. And that was the argument that we made in crafting this architecture, and it was, believe me, fully accepted because people, below the top line do kind of understand that there are these differences. And then after we got it all done and got approval for this architecture, some of the senior ranking Air Force guys to me and said, thanks. Thanks a lot. We really don't want you messing around in our production line. You'd be stupid to use the EELV. And so we said, okay. Now, we may very well use it for cargo deployment. In fact, I would hope to. But as a crew carrier, I'm not saying it can't work. And if you spend money on it, you can make it work. I mean, you can make anything work. But as it is today, it's not that well suited. Did I answer your question? Okay. There's an awful lot of stuff that goes into these engineering trades, It's just really annoying. In the back.
This whole exploration of Moon and Mars is wonderful, commendable, and expensive, as is the International Space Station, as is the Space Shuttle. And I'm happy to give you my 30 cents instead of 15 cents to pay for this, but most of the nation is not. And so you have been moving forward with this within somewhat of a static budget, meaning there are concomitant reductions in other of NASA's operations. And I'm wondering, what are the painful cuts that you need to approve in order to do this within a static budget? And in particular, the ones about the Earth monitoring over the next century.
Well, Earth monitoring is a NOAA responsibility, not a NASA responsibility. We help develop the technology, but we don't pay for the Earth monitoring systems. By and large, unless there are research activities, and the Earth Science Program is something I'm happy to say where I have restored budget since returning to NASA rather than taking it away, and you can look at the record on that. Your statement is obviously pejorative, and but I will try not to address it in that manner. The money that we're spending on NASA probably will not go up and probably will not go substantially down. Because there are political objectives and goals that go well above my head that would act to keep it from going up substantially or down substantially. And the science program at NASA is valued for itself and will not go substantially up or substantially down. I would argue that actually the highest priority would be to restore some help to aeronautics, but the aeronautics budget is not currently as robust as I would like it to be entirely apart from any considerations of space exploration, but having to do with other policy objectives. So the net of that statement is that we spend a certain amount of money on human spaceflight in the country and probably will continue to do so because the NASA top line in constant dollars isn't going to get altered a lot, and neither is the science portion. So the vision for space exploration is largely about what do we do with the money we spend on human spaceflight. I and many others believe it is strategic and that it is important to the United States to do it. Many disagree. I fully understand that. But the argument is that if we are going to spend this money on human spaceflight, then exploring space beyond low Earth orbit is a more productive, more strategic, more important use of the money than is remaining in Earth orbit and being confined to the space station. I must disagree with your assertion that seemed to me to say that most people did not support these objectives. I actually was a little bit surprised, but the Gallup folks ran a poll in December that I thought was unusually well worded. They got beyond the usual rather coarse policy sampling that yields a rather ambiguous answer, and they phrased the question in the following way. Given that the budget for NASA remains less than 1% of the federal budget, and currently we're at 0.7%, given that it remains at less than 1%, do you strongly support, are indifferent about, are mildly against, or strongly against. And then they listed the goals of the vision for exploration, return to the moon, go to Mars, all that. 75% of the population either supported or strongly supported those goals given the precondition. And actually it was about 77%, I'm rounding down. And the spectrum of approval was gender indifferent and political party indifferent to within, the accuracy of the sampling. So when people understand, most people, I would offer from informal sampling, that when I just talk to casual observers, most people believe that the space program uses an amount of money somewhat comparable to DOD. It's amazing how you talk to people, they'll say, what do you think we get at NASA? And they say, half what DOD gets? And I tell them 4%, and they're stunned. I tell them that we spend less than 1% of the budget on NASA, and they think it's pocket change. It's not an issue for them. So given that the amount of money being spent is not an issue, the issue then becomes, what do you think the productive use of that money is? And I believe, or I would not have taken this job, that the proposed effort is a more sensible use of the money than other efforts upon which we have been engaged. And that's the best answer that I can give you as to what we're doing and why we are doing it. In the middle, you were the first one.
I won't use the microphone. Thanks for coming this afternoon. I'm a former employee of NASA headquarters in D.C.
I'm sorry for you.
But I'm broke because I'm an MBA student, not actually. But anyway, my question has to do with some of the newest exploration of space coming from the private sector. Some of the more interesting and novel approaches in exploring space comes from private money, such as the X Award, and also some of the other groups that are encouraging some of the private groups to explore space. How do you regard some of these private groups that are exploring space? Do you look at them more as a possible competitor? Are they taking away from some of the shuttle, some of the launch windows, or some of the financial incentives that you can provide in the future? Or also, do you regard these groups from more of a collaboration standpoint? Can you use some of their low-budget techniques in coming to space and in terms of working with them in the future?
If only because I'm getting to an age where I can no longer remember really long questions. I hope we can get shorter questions in the future. But I think the essence of your question was, how do we regard, what do I think of and how do I regard commercial enterprises, and, with the precondition that they're more innovative. Yes, they are, and I'm desperately hoping that they succeed. Which is why I've advocated and am advocating for a $500 million allocation of NASA money to help seed those enterprises in the next few years. By and large, the innovative commercial enterprises that have been offered up so far, I made this comment earlier in visiting with some of the students, are mostly pretty view graphs and loud mouths, which is fine. Any good idea actually is going to start with that. And the question remains as to which of the entrepreneurs can turn pretty view graphs into pretty hardware. I hope at least a couple do, and we are trying to provide that seed money. I recognize that NASA has a reputation in the past of trying to stifle commercial initiatives as if they were competitors. That is wrong and wrong-headed. It is against the policy of the U.S. government since the Eisenhower years to allow government to compete with what can be offered commercially. In my view, when you use the term exploring space to refer to putting humans in orbit, you may be accurate, but that's unfortunate. Putting a human into orbit was exploring space when John Glenn did it the first time. If we had conducted our space program properly and properly involved industry as early as we could rather than as late as we could, putting people into space would be a routine activity that companies could do without our help and without our involvement. And we could merely buy tickets, which is not to say that the government wouldn't have its own systems. I mean, the government finds it advantageous to buy me a ticket on United Airlines to come up here, and the government finds it advantageous to maintain military airlift capability to move its folks around, and they manage to coexist quite successfully. So I believe being at either end of the spectrum is wrong. And we've been operating in NASA as a strictly government enterprise for moving people and things around for far too long. So I'm doing everything I can to sponsor the development of truly commercial capability over the next few years. Now, it's a chicken and egg thing. I said I'm putting $500 million in it. Why don't I put more in? Some of the entrepreneurs want me to put in more, starting with the presumption that any money we spend in the government is wasted. If we would only give it to them, we would get good value. Well, guess what? The taxpayers are not fond of betting large amounts of money. The Congress will not approve speculating with large amounts of money on a gamble that a supplier may or may not show up. We have a space station to sustain. We want to return to the moon. We have to conduct our affairs in such a way that when we spend money, we definitely get a product. I can't fail to accomplish the stated mission because I bet on an entrepreneur who might or might not be there. So I'm treading a fine line between not doing anything to help the entrepreneurs and risking the non-accomplishment of my stated mission because I trusted entrepreneurs who turned out not to be there. It's a difficult path to walk, and I'm trying to walk it because I'm convinced that if the government can't provide some seed funding and frankly some seed demand, that we won't be able to leverage this economy. For example, looking back historically, I cannot imagine the development of the American West without the government-sponsored transcontinental railroads. Okay, I cannot imagine that would have happened. We would not have developed the West with wagon trains and mountain men. You know, the development of the American West began in the last third of the 19th century after the railroads were there. So there is a role for government in helping to seed private enterprise, and I want to do that desperately and frankly looking for ideas. So I hope some of these folks that you mentioned can get to the next stage beyond view graphs. Ma'am.
Thanks for coming here today. I'm a research scientist here at MIT, and I've had over a decade of very nice funding from NASA. However, recently we had catastrophic, unprecedented cuts in our ongoing projects. And so my question is, does NASA envision reestablishing any funding in medical and cell science researches?
Eventually, yes. But let me pose to you the following dilemma. Oh, I'm sorry. The question was, her life science research has been cut, and what do I plan to do about it? Well, I mean, that's the net of the question. Sorry. And the answer is, right now, nothing, because I'm responsible for trying to complete the space station according to a long-standing and highly interlocking set of international agreements that we have, I think appropriately, chosen to say we will honor. I'm trying to fly out the shuttle and retire it in 2010. I'm trying to build a new system, have NASA build, through its prime contractors, a new system to replace the shuttle's capabilities, trying to keep the overall space science program as intact as I can and not further hurt aeronautics. Life science research for NASA is not the only life science research in the nation by any means. In fact, we're not even the primary user. Life science research at NASA has the sole purpose of trying to figure out what's going to happen to human beings when we put them in space. Well, I don't have any interest in finding out what happens to human beings when I put them in space if I can't put them in space. And so, and I'm not being cavalier about that, although it sounds that way. It's just because I get the question a lot. So I have a limited budget, a lot of requirements on the plate, and a necessity of making some very hard choices, which involve cutting some things I would very much like to do. Because I think the priority order has to be to restore, for the United States, a set of capabilities that we once had, that we allowed to atrophy, that we now wish we had not allowed to atrophy, and that we must recreate. And I need more money than I've got to do that. And so unfortunately, for the next 4 or 5 years, most of the research activities you have come to know and love from NASA are going to be reduced. Now, we had proposed some cuts in research and analysis in our purely space science budget, which would not help this lady. and we may actually decide to cut a mission and restore some of the RNA money, because I'm very aware of the frustration among the scientists at losing, graduate student support and things like that. I've been a graduate student. We may rethink that. We can do that. But broadly speaking, I just don't see an opportunity for much life science research within NASA for the next 5 or 6 years. I just am out of money. I wish I could give you a better answer. On the left, haven't had any attention over there.
I wonder if you could walk us through the airlock decision.
What airlock decision do you refer to?
I think I've heard that there was a high-level requirement that the airlock on the lunar lander, and so I was wondering if you could walk us through.
Okay. I mean, even high-level requirements can always be scrubbed. As I've pointed out several times, the lunar lander is not designed yet. But in our thinking is, yes, the requirement for an airlock for the following reasons. If people are going to go to the moon and stay for more than 3 days, if they're going to stay for a week or weeks at a time, which the system is capable of supporting, they, of course, need to have a relatively habitable environment in which to live. Lunar dust is... the more we study it, the more harmful we understand that it is. It's basically finely blasted rock, which is quite sharp and we think quite toxic to humans. So we don't want lunar dust cluttering up the actual habitation space. I've phrased this inappropriately. We want as little lunar dust as possible cluttering up the habitation space. If we drag suited crew members into an area of the lander or any of the other lunar habitat things, then we will inevitably have a huge amount of dust there, and it will be problematic. Now, if you knew that you were only going to use the lunar lander to land, and get out of it, and not get back in it until you were coming back home, or coming up to orbit for a rendezvous, and definitely had another habitation module, then you wouldn't need the lunar lock in the lander, and you could put it in the hab module. I'm trying to look out 15 or more years in the future and guess whether there's enough money in the program to guarantee that I'll have a lander plus a habitat. And I can't guarantee that. At least I don't think I can. And so it's a little bit of a suspenders and belt approach. If I've got to live out of the lander for a while, then I want an airlock. That's the thinking. I don't think I'm Moses with a set of stone tablets that I carried down from the mount. I look in my closet every day to see if those tablets are there telling me what to do, and they weren't there this morning. So a lot of this is human judgment. But yeah, I'm the guy that said there's got to be an airlock, because there was a lot of dispute about that on our team. So at some point, somebody's got to make a decision. So I said there shall be an airlock, and those are the reasons why. I mean, sometimes it comes to that. The toughest decisions are the 55%, 45% kind of decisions, and nothing ever comes to the boss that's easy, or somebody else would have done it. So that was the thinking. Way in the back on the left.
Yeah, I was wondering if you could comment on an alternative view I've read in the piece. It seems obvious that you need a heavy lift vehicle, but someone once wrote a piece recently saying that there's a lot of economic and technical reasons that put together it makes a lot more sense to have a smaller launch vehicle and launch a bunch of pieces and send them up in orbit. But you must have considered that possibility to reject it for some reason.
Yes, on the grounds of obviousness. That's not a good strategy for a couple of reasons. The first of which is that any payload that goes to the moon is 50% of it is propellant, and a large fraction of that is hydrogen. And it might well be that the most difficult technology of spaceflight in our era is preventing liquid hydrogen from boiling off. I forget the rates, but it's significant. So that if you intend to leave a liquid hydrogen powered stage in orbit for any length of time, like weeks and months, many percent of the propellant load will boil off. Now we can argue how many percent is and how much effort I can go to thermally isolate the payload, but it's a difficult problem. If I'm going to assemble a lunar payload of say 50 or so metric tons, which is, it's kind of hard to do it for much less than that unless I can shrink people. An EELV, for example, using that payload capacity to get all the stuff up that we needed in low Earth orbit or on the way to the moon, the minimum anybody was able to come up with was a scheme that, you know, had at least half a dozen EELV class launches. So then I used to be in this business. You go down and talk to the guys who launch Atlases and Deltas, and you know they might get off one a month if it was really pushed. And who else is going to be able to do a lot better? So it now takes 6 months to assemble a payload to go to the moon, of which, you know, the liquid hydrogen is sitting there boiling off. And the pieces and parts don't join together well. The whole logistics strategy for, I don't think we'd get permission to go if we needed 6 launches minimum or more for every time we wanted to head for the moon. Moreover, if I need that many launches every time I want to go, or more, the standard version had 9, and if you think I have a 98% probability of success on any given launch, multiply 90.98 to the 9th, and you probably won't like the reliability number. So if any one of those launches fails, I've now lost the whole mission, right? And I'm not even talking about crew fatality, I'm just talking about an important piece of the overall mission assembly didn't go. So for reasons of logistics, for reasons of packaging, for reasons of fuel, propellant tank technology, and for reasons of reliability, we decided that it was best to have fewer launches. If I had pieces and parts that it could all be done easily in one big launch and still give us the kind of capability we need, we might have done that. But that was the answer. I'm giving you verbal arguments, but we reduced all that to numbers. And oh, by the way, it was hugely cheaper not to do half a dozen or 8 or 9 launches. It was hugely cheaper. So we subjected it to the most rigorous analysis we could, and it wasn't even a close call. Over there.
I understand that.
Now, I'm sorry, over on the side of the room, has had his hand up for a while.
We have 4 science ladies budgets. We have the commercial guy who wants some more money. You mentioned wanting to do commercial stuff. Could we achieve positive time impacts on CEV and positive budget impacts that could go back to the nice science lady if we use more commercial stuff? And could that, could we get more synergy out of that?
Well, maybe, but again, back to chicken and egg, not in the next 4 or 5 years because there is no commercial capability. So if I enable it now, then in 4 or 5 years it might be there, in which case, if it is, it will hugely reduce our logistics cost to space station, and I will be able to put that money back in other things. That's why I'm investing now.
Could we consider spinning off some of those mandates for a few years to other organizations, other agencies in the government that might be willing to handle that in the next 4 or 5 years?
No. Look, there's a couple of government 101 things here that you need to understand so that you don't ask questions like that again. Government agencies are not allowed to make up their own missions. I can't, I don't want to, but my feelings about it are irrelevant. I can't decide on my own either to acquire or shed missions. Other agencies can't decide that they will accept a mission requirement that I give them. The charters of the different federal agencies are enshrined in legislation. There is a 1958 Space Act as amended that created and charters NASA to do certain things. Charters the DOD, all the agencies are like that. I don't get to just decide what my charter ought to be. Such decisions are not accompanied without an enormous amount of groaning and screaming throughout all of government if they need to be adjusted. I can't imagine a policy environment in which just having decided within the last couple of years what NASA's purpose was going to be for the next 20-some years, okay, and having just been approved by the Congress, if somebody says, oh, by the way, now we think we'd be better if some other agency handled the Earth-to-orbit transportation problem. It's not, politics is the art of the possible. This is just not something which is even possible. Okay, now, if I can get a successful commercial investment going, then I can use NASA dollars to procure commercial services. And I will, absolutely will. But I cannot offload that on some other agency. It's just not there. All the way in the back.
Mike, if somebody like Donald Trump or George Lucas was to offer $5 to $10 million to the winner of a certain debate, would you or anybody at NASA debate Richard Hoagland and either he's a bum or his ideas are great and just decide one way or the other and be done with it?
Who is Richard Hoagland?
The face on Mars. The face on Mars.
Oh, I'm sorry. Yeah, I'm not going to address that. There is no face on Mars. It's a land formation. Stop. I mean, stop me or I'll shoot. In the back. Yeah, sorry. Okay.
I was wondering if you any idea when the astronaut selection process might be restarted.
I've got 140 some astronauts, I think. I hope I got the count right. And something like 70 of them haven't flown.
But I'll work for free.
Take care of yourself and stay in good physical shape for the next crew selection. And we've got 16 shuttle flights plus one for Hubble. And there's only so many rookies we can carry on each flight. And it's fairly obvious that we won't even be able to fly all the folks we've got, which is very regrettable. I mean, you know, I just, those are the mathematics. So no, I don't think we're going to be selecting any more astronauts for a little while. I'm sorry. Center there, because you're under the light and I can see you.
As you know, there are many system studies have shown that electric propulsion can improve payload mass and decrease costs to Mars and, of course, and beyond in the solar system. So I was wondering if you could address the cancellation of most of NASA's electric propulsion funding and when you see it coming back.
Well, I see it coming back when I have money to pay for it. The Prometheus program was scoped out at $11 billion, and that was before any hardware had been cut. There's just not $11 billion in, I mean, maybe there's some parallel quantum universe, according to the many worlds theory, in which there is $11 billion for NASA to spend in this era on electric propulsion, but it isn't the universe I'm inhabiting. That just is not going to happen. Yeah, electric propulsion, if we developed it, would be really neat. It's a great way to move cargo around. I would love to have money for space nuclear thermal propulsion and for space nuclear power, which would feed into the electric propulsion. I would just love to have money for all that stuff. Don't have it. I think NASA's in a place where we have the money we're going to get. We have to demonstrate that we can do some neat things with that money, things that are strategically important to the United States and which excite the public, and we have to do those things well. And this has got to occupy us for the next half dozen to a dozen years. And when we do that, when we demonstrate once again that we can execute missions with skill and cunning and daring and innovation and be reliable in doing what we say we can do, then maybe people will listen to us when we say we would like to go beyond. But we have some things to prove. Back there.
Can you comment at all on how you might use this hardware for Mars missions? System engineering, say you want to use common hardware for both.
Well, sure. The reason why the lunar architecture looks the way it does is that the Earth orbit rendezvous sequence we have is a little piece and a big piece. Well, the big piece is big enough that within 4 or 5 launches, spaced out over, off 2 launch pads, 39A and B, that are probably going to be with us for a while, within a few months we could put together a Mars payload launched in 125, 100 metric ton chunks. That's about the size of a payload that you need to go to Mars. If you've studied the problem at all, I'm sure you've come out with that same conclusion, because everyone else who's ever looked at it has said it's about 1 space station mass equivalent to go to Mars. And I don't think we want to spend 15 years doing it. So the lunar architecture looks the way it does in order to provide a heavy lift or leave behind. The CEV looks the way it does because it's a vehicle which, among certain other choices, but it is one choice, which can bring a crew back from Mars return velocities. Fundamental purpose of the CEV is to get the crew, the first 100 miles up and the last 100 miles back. Going to Mars, we will live in a habitation module of some kind, maybe derived from what we do on space station, maybe not. But we will clearly need more than just the CEV and the heavy lifter. But we will need those, and they look the way they do in large part so that what we're doing for the moon can transfer over to Mars. Now, not with any thought that what we're doing for the moon is everything that we need for Mars, far from it, but that at least what we develop to go to the moon should be useful in going to Mars. In the orange shirt?
What are the lessons learned from ISS regarding international collaboration in human spaceflight?
I've said many times, but only because I believe it, that the international cooperation, the pattern of international cooperation that we've gotten out of the space station program will be its most lasting legacy. Because the hardware will eventually come down. But we have forged over the last 20 years partnerships with Europe, Japan, Russia, in very difficult circumstances, in many cases. And those partnerships have hung together through exigencies that I would have predicted, and in fact did predict, would destroy the partnership. So I was wrong. They've held together quite well. I had a heads of agencies meeting last week. The partnership is solid and strong. We hope to take it with us to the moon. We hope to add partner nations. And we certainly hope to take it with us to Mars. Thanks for your economic analysis. The part of CEV which is reusable or might be reusable is the command module, and it is indeed an interesting question as to whether it ought to be reusable or not. The reason why I've asked that it be reusable is that if I don't ask the question, I can guarantee that I will only get one answer, and that is that it should be expendable, and the contractors would love nothing more than to build a new one for me each time. In point of fact, the Apollo command module was reusable. We just didn't reuse it. I mean, it could have even been reused on a lunar mission without replacing the heat shield. The heat shield was so over-designed. But we didn't plan to do it and didn't. So the question I'm asking our team is, essentially, why can't it be reusable? And if you want to reuse it, how would you design it to make it so? And if the answer comes out to be prohibitive, we won't do it. It's really an economic question. Our cost modeling people, who I've known for a long time and truly believe to be the best in the world, indicate that if we can get 4 or 5 reuses out of a command module, we get over the knee in the curve for the non-recurring engineering to make that statement come true. And if we get 10 reuses out of it, we really make money like a bandit. So we're not trying for, the shuttle will fly 100 flights kind of reuse. We're trying for 5 or 10. And if it doesn't make sense, we won't do it. Since you already seem to know the answer, maybe you can just phone up my cost model guys and tell them, and I can get them working on other stuff. But all joking aside, we're trying to take an unbiased look at it and see. Reusability is obviously not a technical issue. It is obviously doable. The question is, what does it cost to do it? And does that cost pay for itself? Don't know yet. Sir.
I'm former Russian rocket scientist. Would you give more specific answer, just mention the question? Your vision with relation
Well, I don't know.
Well, answer me just,
I will try. The Russians have been superb partners. They have done what they said they would do in a period of great difficulty for the United States and for the international partnership in space station as a whole. I believe that when the space station gets assembled, we will all use it. We will find ample use for it. But I believe then that the partner nations will want something new to do. And I believe that Russia will want to be a part of that. We can't hold a gun to their head and make them, but I believe that Russia will want to be a partner with us. As one now of 3 nations in the world with their own spacefaring capability in terms of human spaceflight, I would like to have them on board. And there will be places for them. But they need to be volunteers, not draftees. I mean, I can't make them do it. So ultimately, it will be up to the Russian president and the Russian Duma. So, как поживаете? Sure. A couple more questions. Yes, ma'am.
Can I message countries like China and India to join us in the future?
The president has already extended an invitation to India to invite closer space cooperation with the United States on his visit last week, and I'm looking forward to that. Relationships with China are, as you know, sometimes difficult. I look at the space program as a way to make those relationships easier, and I hope that a way can be found to encourage such cooperation. Right now, such cooperation in space with China hinges on larger issues involving defense and human rights and trade and other things that go well above NASA, and so I really just can't comment on that at the present. In the back.
Yeah, so you talked about what you need from entrepreneurs and companies. What do you need from us, research universities?
Turn out great students. I'm not being flip. Universities exist first and foremost in my mind, and I've been to enough of them, exist to educate. I was mentioning to a student earlier who asked that question, I said, you're equipping yourselves as students, not as you professors are equipping the students with the tools that you're going to be using for a 40-year career. Build those tools well. Because you're never going to get as much opportunity to learn and grow as you have here at the university. So that's the first thing. The second thing, of course, is that, I would be hard put to think of anything that we do at NASA, whether it's robotic science missions or, space architectures or, in many cases, very specific subsystems and instruments where universities and university laboratories are not involved. The Draper Lab grew out of, and the Lincoln Lab grew out of such interactions. I came back to NASA from Johns Hopkins University's Applied Physics Laboratory. I worked at the Jet Propulsion Lab. They're operated by, other great institutions, Johns Hopkins and Caltech. The space enterprise involves universities at every level. One of the things that I hope we do, and maybe the most important thing, really, is to be doing the kinds of things in space that make students want to do difficult stuff in order to be part of it. That may be our greatest value. Sir?
What is your, have you thought of your long-term strategy of switching the moon program to a Mars program? It seems like you might be locked in to the moon, at least budget-wise, when you try to go to Mars.
Well, the decision of what we do at the moon versus when we transition to Mars will be made by future administrators and future Congresses and future presidents. I've tried to craft and to supervise the crafting of an architecture that allows, but does not require, someone to develop a lunar base, and that allows, but does not require, a transition to Mars based on the CEV and the heavy lifter, and again, we need some additional stuff to go to Mars. there is not a technical need for, and there is not a budgetary possibility of beginning work on a Mars architecture today. First things first, we're trying to finish the station, fly out the shuttle, rebuild a capability to get back to the moon. Now, next year, when I walked into NASA, we were 15 months late, as far as the Congress and the White House viewed it, of putting forth an architecture for how we would merely return to the moon and how we would replace the shuttle. And my overseers were not reluctant to let me know that. So in the last 11 months, we've put together an architecture which everybody seems to find acceptable. Not elegant, but acceptable, for replacing shuttle crew and lift capabilities, for getting people back to the moon, for sustaining the space station, for showing a path to Mars. So this year, we're going to talk about, with our international partners, and next year, what we're going to do on the moon and who we're going to do it with. And then, as that begins to get firmed up, we're going to talk about how we will use these pieces and parts and partners to get to Mars. I think it would be, you know, one of my favorite movies is John Wayne's True Grit, where these guys are squaring off against each other on opposite sides of a clearing, and one of them insults the other, and they say, that's bold talk for a one-eyed fat man. I think it would be bold talk for a one-eyed thin man if I were to start prescribing in gross detail the architecture and timing and transition from lunar-based activities to Mars-based activities when the 2020s are about the earliest we can see that coming true. I'm just hoping to be, you know, above ground in the 2020s. So it's not that we don't care, it's that I think it's a little premature. Okay, I think we're done.
And I think that last answer on the dream of going to Mars will get us all excited and go home, because there's probably Martian blood flowing in all our veins. That's what we all dream about. Mike, it's been great having you here. Thanks so much.
Thank you.